automatic fire suppression systems control and extinguish fires without human intervention. Examples of automatic systems include fire sprinkler system, gaseous fire suppression, and condensed aerosol fire suppression. The first fire extinguisher patent was issued to Alanson Crane of Virginia on February 10, 1863. The first fire sprinkler system was patented by H. W. Pratt in 1872. But the first practical automatic sprinkler system was invented in 1874 by Henry S. Parmalee of New Haven, CT. He installed the system in a piano factory he owned. Types of automatic systems. Today there are numerous types of automatic fire suppression systems. Systems are as diverse as the many applications. In general, however, automatic fire suppression systems fall into two categories: engineered and pre-engineered systems. Engineered fire suppression systems are design-specific. Engineered systems are usually for larger installations where the system is designed for the particular application. Examples include marine and land vehicle applications, computer clean rooms, public and private buildings, industrial paint lines, dip tanks and electrical switch rooms. Engineered systems use a number of gaseous or solid agents. Many are specifically formulated. Some, such as 3M Novec 1230 fire protection fluid, are stored as a liquid and discharged as a gas. Pre-engineered fire suppression systems use pre-designed elements to eliminate the need for engineering work beyond the original product design. Typical industrial solutions use a simple wet or dry chemical agent, such as potassium carbonate or monoammonium phosphate, to protect spaces such as paint rooms and booths, storage areas and commercial kitchens. A small number of residential designs have also emerged that typically employ water mist with or without a surfactant additive, and target retrofit applications where the risk of fire or fire injury is high but where a conventional fire sprinkler system would be unacceptably expensive. In addition, residential range hood fire suppression systems are becoming more common in shared-use cooking spaces, such as those found in assisted living facilities, hospice homes, and group homes. Components. By definition, an automatic fire suppression system can operate without human intervention. To do so it must possess a means of detection, actuation and delivery. In many systems, detection is accomplished by mechanical or electrical means. Mechanical detection uses fusible link or thermobulb detectors. These detectors are designed to separate at a specific temperature and release tension on a release mechanism. Electrical detection uses heat detectors equipped with self-restoring, normally open contacts which close when a predetermined temperature is reached. Remote and local manual operation is also possible. Actuation usually involves either a pressurized fluid and a release valve, or in some cases an electric pump. Delivery is accomplished by means of piping and nozzles. Nozzle design is specific to the agent used and coverage desired. Extinguishing agents. In the early days, water was the exclusive fire suppression agent. Although still used today, water has limitations. Most notably, its liquid and conductive properties can cause as much property damage as fire itself. Health and environmental concerns. Despite their effectiveness, chemical fire extinguishing agents are not without disadvantages. In the early 20th century, carbon tetrachloride was extensively used as a dry cleaning solvent, a refrigerant and as a fire extinguishing agent. In time, it was found carbon tetrachloride could lead to severe health effects. From the mid-1960s Holland 1301 was the industry standard for protecting high-value assets from the threat of fire. Holland 1301 had many benefits as a fire suppression agent. It is fast-acting, safe for assets and required minimal storage space. Holland 1301's major drawbacks are that it depletes atmospheric ozone and is potentially harmful to humans. Since 1987, some 191 nations have signed the Montreal Protocol on substances that deplete the ozone layer. The protocol is an international treaty designed to protect the ozone layer by phasing out the production of a number of substances believed to be responsible for ozone depletion. Among these were halogenated hydrocarbons often used in fire suppression. As a result, manufacturers have focused on alternatives to Holland 1301 and Holland 1211. A number of countries have also taken steps to mandate the removal of installed Holland systems. Most notably, these include Germany and Australia, the first two countries in the world to require this action. In both of these countries, complete removal of installed Holland systems has been completed except for a very few essential use applications. The European Union is currently undergoing a similar mandated removal of installed Holland systems. Modern systems. Since the early 1990s, manufacturers have successfully developed safe and effective Holland alternatives. These include DuPont FM200, American Pacifica Euro unregistered trademark S Halotron and 3M Novec 1230 fire protection fluid. Generally, the Holland replacement agents available today fall into two broad categories: in-kind or not in-kind. In-kind gaseous agents generally fall into two further categories: halocarbons and inert gases. Not in-kind alternatives include such options as water mist or the use of early warning smoke detection systems. References